Hello, three dimensions. Hey, here we are finally in what we are living in, three dimensions. So, what do we know that's in three dimensions? We are in three dimensions. Write the result of multiplying three units of measure for length in meters together. And I've done just that here. Multiply m, and I don't know if you can see it, m sub x, m sub y, and m sub z. I put the sub there to indicate that they're all perpendicular to one another. If you take a look at this Cartesian coordinate system behind me, I've added a new line in the z-axis, okay? It's hard to demonstrate a three-dimensional aspect on a two-dimensional plane, okay? But sometimes we try to do that, and you got to use your imagination just a little bit here. But we have a z-axis running through the x and the y. And if you take a look, all three of these are perpendicular to one another, okay? All three of these are perpendicular to one another, okay? So, this is all three different units of measure in three different directions. What does the previous result measure for an object? What does this measure for? What does cubic meters measure for an object? Well, it measures volume. It measures the volume of something. So generally the volume of a cup, of a cylinder, generally is how much that cylinder can hold, right? You have a measuring cup, right? We need 2 cups of flour, 1 cup of water, right? That's a value for volume, okay? There's also liters, also cubic meters, also cubic centimeters, also cubic inches, cubic feet, all those, okay? All right, so how many separate dimensions of radius are measured in 4/3 pi r cubed? What does 4/3 pi r cubed come from? I'm glad you asked. That is the volumetric formula for a sphere, a ball, okay? One of these guys, okay? 4/3 pi r cubed, okay? All right, so if we take a look at a sphere, all right, well, we have, again, an x-axis, a y-axis, and we have the z-axis, right? We have an axis going through them both, through the x and the y, okay? If they are all the same, if it is a true sphere, then they're all going to be the same. They're all going to be r. So we can just measure 1 and call it good. Just cube that r. Bring it to the 3rd power, however you want to say it. If it was an irregular shaped sphere, then we would have problems. That would be another issue. We're not going to be covering that in this class, though. So what shape other than a sphere can simply multiply the measure of only one of its sides 3 times to get the volume? Okay? What other shape can you multiply 3 times other than a sphere to get volume? Well, you can't really even multiply that just 3 times and just get the volume for a sphere, but this next object you can. What object could we multiply just base times height and get the volume? That was a square, right? Square or rectangle? Well, it's similar for its three-dimensional counterpart, which we call a cube or a rectangular prism. We just multiply its side, right? Side times side times side, which is measure one side. You measure one side, you got them all for a cube, right? Like a Rubik's Cube. You measure one length of one of its sides, then you've got them all. So you just take that side measure and you cube it. Side cubed. Whatever you measure, and you measure it in inches, and you just cube those inches. You measured in meters, you measured in centimeters, just take that value, whatever it is, maybe 3 inches perhaps, I don't know how tall they are, and you just bring it to the third power, and then you're done. All right, thank you very much. That was volume. Have a good day.